Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an Associate Professor in the Department of Electrical and Electronics Engineering. So today we are going to discuss another topic from the Electrical Circuits course, which is the definition and terminology from the module, the first module, which is Introduction to Electrical Circuits. So in today's class, let us discuss some basic definitions which are related to the introduction to electrical circuits. Okay, so because these definitions and terminology is very important to understand the course in detail. So first, let us start with define voltage. So what it mean by voltage? Of course, there are many definitions, because if you understand what is voltage, then we can write in our own words what is mean by the voltage. So how we can represent the voltage. So here, the definition is, of course, this voltage is also called as a electromotive force, or in another word, simply we write it as EMF, electromotive force, or voltage, both are same. So we can call, sometimes it is electromotive force and sometimes it is voltage. So of course, the voltage is expressed in quantitative expression, which means like how much voltage, okay, whether it is some quantitative. We can quantify either 30 volts or 60 volts, whatever it is. Okay. So it is a quantitative. So here the definition is the voltage or the electromotive force, or we can also call it as a potential difference, is defined as is a quantitative expression of the potential difference in charge between 2 points in an electric field. So that's why here, suppose if there are 2 points in an electric field, so the potential difference between these 2 points A and B, or in sometimes you can call it as VAB, the potential difference between these 2 points in an electric field is called as a voltage or the potential difference. So the unit, so how we can measure this voltage, or how quantify this voltage, okay, so which is in volts. VOLTS, which means, so suppose if the potential difference between these 2 points is, let us consider 30, then 30 volts. So the unit for the voltage is the volts. We usually, instead of writing the full word volts, so we usually represent, suppose 60 volts means 60 V. Okay, the capital V or the small v, but usually we represent with the capital V. Then the next definition is define flow of charge. So we know the flow of charge or the flow of electronics is called as a current. So current is defined as the flow of electrons or the flow of charge. So here the flow of charge is, the rate at which the electric charge flow in a conductor. That is called a current. Okay. So at what rate the charge is flowing through a conductor is called as a current. Then it is which means the number of electrons passing through a point in a second. The number of electrons passing through a point in a second is called as a current. So, which means if more number of electrons passing through a point represents, the more current is flowing through that particular point, or more current is flowing through that particular conductor. So here the current is depends on, so how many number of electrons passing through a point, or passing in a conductor in a second, or exactly, passing through a point, passing in a given point, okay, in a second is called as a current. So which means, and here of course we usually charge means Q, and especially in the charge, positive charge is there, negative charge is there. So positive charge we represents the plus, and negative charge we represents negative. So usually this negative charge is the electrons. Okay. So how many electrons that are passing through a given point is represented by a current, and the more number of electrons flow through a particular point, which means the more current is passing through that particular point. Then power. So as we know, simply what is power means, we can say like voltage into current. P is equal to V into I, that is power. But what exactly the power? Because here we are we are considering the electronic as a charge. Okay, so power either, I mean, it is an electric power that we are defining. Okay, so the rate at which the work is being done in an electrical circuit is called as an electric power. So usually this power is nothing but the work. Suppose if there is a displacement, then the work has been done. Okay, if you apply some force, then that particular object will displace or move from one place to another place. So which means the work has been done. Okay, so that is the mechanical work. Okay, or the mechanical power that, okay, then here it is an electrical power. So that's why here also the rate at which the work is being done. So the work means here the current. Okay, work when the electrons moving from one point to another point. Okay, so which means work has been done in an electric field. So that's why this is an electrical power. So the rate at which the work is being done in an electrical circuit is called electrical power. Or in other words, the electric power is defined as the rate of the transfer of energy. Okay, at what rate then the energy is transferring through a particular point is called as a electrical power. So how then electrical power can be generated? So of course we know the simple, the electrical power can be generated by using a generator. Of course there are many ways, okay, but the the traditional way is the electrical, by using the electrical generator. And also we can get the power from the batteries. Of course, again, to get charge the battery, again we need power to charge that battery. Okay, so that is mean by the power. Of course, this electrical power can be converted into different forms. Either you can convert, because suppose if you take a motor, the function of the motor is it is converting electrical energy into mechanical energy. So which means that by using the motor we can convert the electrical power into mechanical power. And suppose if you take a heater, so the heater also input is electrical energy and output is the heat energy. So the heater can convert the electrical energy into heat energy, right? So like that we can convert the electrical energy into various other forms by using the various equipments. Then state Ohm's law. So this is one of the basic law related to the electrical circuit. So without Ohm's law there is, because here electrical, first of all we should know what is mean by the electrical circuit. So the circuit is, okay, formed by an active elements with one or more energy sources. Okay, that is called, and it should be a closed, it should be a closed loop. So that is mean by the electrical circuit, which means suppose if you take some resistor R1, R2 with some energy source. So let us consider voltage. So this is called an electrical circuit, right? So here the Ohm's law, it states that the current through a conductor between 2 points is directly proportional to the potential difference across the 2 points, which means let us consider a conductor. The 2 points, the two ends of the conductor is A and B. So according to Ohm's law, the current through a conductor between the 2 points, which means the current is flowing through a conductor between the 2 points from point A to B. So let us consider here it is current I, which is directly proportional to the potential across the 2 points. So the potential across the 2 points is, let us consider the voltage VAB. So here VAB, that is potential across the 2 points, is directly proportional to the current flowing in between the 2 points, right? So if you eliminate the proportionality, then V is equal, in other terms, simply V is equal to I into R. So here R is the constant and here R is the resistivity of this particular conductor, or the resistance of this conductor. Of course, every conductor having an amount of resistance. Okay, so that will vary based on the conductor to conductor, but every conductor having some amount of the resistance. So that is represented by the R. Okay, and another thing, at constant temperature, that is very, very important. Okay, so this Ohm's law, which means the current through a conductor between the 2 points is directly proportional to the potential across the 2 points at constant temperature. That is the Ohm's law. Because if you won't consider at constant temperature, then this relation will not obey. Okay, so that is the Ohm's law. Then the another two basic laws which are related to the electrical circuits. So basically these laws used, okay, Kirchhoff's laws, we usually call it as a Kirchhoff's laws. So these Kirchhoff's laws are mainly used to reduce the network, are mainly used to find a current, okay, or find a response at any point of the circuit. Response is nothing but either it may be current or it may be voltage. So which means, suppose again, let me consider the same circuit having the two resistors, and this is the voltage source. Let us consider, so plus and minus, okay, and let us consider this is R1, R2, and this is the current flowing through this particular circuit is I, and the voltage across R1 is V1 and voltage across R2 is V2. Suppose if you want to find the response, which means voltage or current at R1, so what is the current flowing through the resistor R1 and what is the voltage across the resistor V1? Then how we can find? By using these Kirchhoff's laws. These are the basic laws for the network reduction, right? So here, first of all, the Kirchhoff's law, which is related to the current, that is called as a Kirchhoff's current law. So here Kirchhoff's current law, or we can also call it as a Kirchhoff's first law. So there are two laws, Kirchhoff's first law and second law. So the first law is also called as a Kirchhoff's current law, and the second law is also called as a Kirchhoff's voltage law. So here, according to the Kirchhoff's current law or the Kirchhoff's first law, the total current in a closed circuit, okay, or the entering current at node is equal to the living or the current living at the node, okay. So which means, suppose let me consider another circuit, this one. So let us consider these resistors are R1, R2 and R3. This is V. Then the current flowing through this R1 is I1. And here, okay, let me consider here also one more resistor. Then let me consider this is, so here it is, let me consider R2 and this is R3 and this is R4. So the current flowing through the I2 is R2 and this is I3. Let us consider. Okay, so according to Kirchhoff's current law, the algebraic sum of the currents entering towards the node is equal to, okay, the sum of the currents leaving from the node. Or in other words, the algebraic sum of the currents at a particular node is equal to 0. Okay, so this Kirchhoff's current law is related to the currents in a circuit, the various currents in a circuit, or it will define the relation between the currents in a circuit, okay, and with respect to the node. So here, with respect to this particular node, according to the Kirchhoff's current law, so the sum of the currents entering towards the node is equal to the sum of the currents leaving from the node. So what are the currents entering towards the nodes here? It is I1, which is equal to, what are the currents leaving from the node? I2 and I3. So I2 plus I3. So this is according to the Kirchhoff's law. So the relation between the various currents in a loop. Or in another word, the algebraic sum of the currents in a particular loop is equal to 0, which means here, okay, if you send these I2 and I3 to the left hand side, then I1 minus I2 minus I3 equal to 0. So this equation and this equation both are same. So here, the algebraic sum of the currents at a particular node is equal to 0. So this is the Kirchhoff's current law. Then coming to the Kirchhoff's voltage law. So this is also called as a Kirchhoff's second law. And according to the Kirchhoff's voltage law, the algebraic sum of the voltage in a closed loop or closed circuit is equal to 0. Okay, the algebraic sum of the voltages in a closed circuit is equal to 0. So here this Kirchhoff's voltage law is associated with the loop, okay, and the Kirchhoff's current law is associated with the node. So here let us consider, here it is V, here it is R1, and here it is R2, and here it is V1, and here it is V2. Okay. Then here, according to the Kirchhoff's voltage law, V is equal to V1 plus V2, or in other words, V1 minus V2 is equal to 0. So here, again, this equation 1 equal to 2. So this is the Kirchhoff's voltage. Then, energy sources. What are the various types of energy sources that we are using in a electrical circuits? Basically, there are two types of energy sources that we are using. Of course, these are electrical energy sources. One is voltage source, another one is the current source. And again, these energy sources can be classify based on whether these are independent or dependent. So first, let us discuss about the independent energy sources. So the independent energy sources are which does not depends on any other quantity in the circuit. Which means let me draw again here one simple circuit. Having two loops, R1, R2, R3. So let us consider here V. So here the V is independent of the current flowing through the resistor R2 and R3, or the voltage across resistor or voltage across resistor R3. Right? So this is independent. So that is what independent energy source. If it is a current source, then let us consider if it is I, then I. So independent current source and independent voltage source. Then dependent. So if you understand dependent, then you can easily understand the independent. So dependent source, here actually dependent sources can be classified into four types. One is voltage controlled voltage source, and voltage controlled current source, current controlled current source, and current controlled voltage source. Which means, first let me draw the voltage controlled voltage source. So the voltage controlled voltage source is nothing but, of course this is a voltage source, but this voltage source is controlled by the voltage across the another resistor. So let us consider this is R1, R2 and R3. So here the voltage across R1 is V1 and this is V, and the voltage across R2 is V2 and the voltage across R3 is V3. Suppose if we write V is equal to 3 into V3. So which means here the voltage source value V is depends on V3, which is the voltage across the resistor R3. So that's why here this is voltage dependent voltage source or voltage controlled voltage source, because here these voltage source is controlled by the voltage across the resistor R3. Which means suppose if V3 is equal to, let us consider V3 is equal to 2 volts, then here this voltage source 3 into 2 is 6 volts. But if the V3 is equal to 3 volts, let us consider, then here it is 9 volts. So which means this voltage source is controlled by the voltage across the resistor R3, which is V3. That's why it is a voltage controlled voltage source. Similarly, voltage controlled current source. So the voltage controlled current source is nothing but, suppose let us consider the same circuit, and here the current flowing, let us consider, and this is of course this is I1 and this is I2 and this is I3. So here V is equal to 2 into I3, let us consider. So which means here the voltage value V is depends on or is controlled by the current I3. Same way here, suppose I3 is equal to 2 amperes, then here it should be 4 volts. And if I3 is equal to 3 amperes, then here it is 6 volts. So which means here the voltage source value is depends on the current, or this voltage is controlled by the current flowing through the resistor R3, which is I3. So that's why here it is this is current controlled voltage source. So this is current controlled voltage source, because here this voltage source is controlled by the current. So that's why here it is current controlled voltage source. So both are voltage sources only in this case and this case. But in the first case, this voltage source, this voltage source is controlled by again the voltage, the voltage across the other resistance. And here again this voltage source is controlled by the current flowing through the other resistors. That's why here it is voltage controlled voltage source and current controlled current voltage source. The similar way, if you take here it is the current source. So which means here I is equal to 2 into I3. then this is current controlled current source, which means here this one. Current controlled current source. Because here this is the current source. This current source is controlled by the current which is flowing through the resistor R3. So that's why this is current controlled current source. Next, the differentiate active and passive elements. So active and passive elements are nothing but, okay. So here the active elements are, those are energy producing or not producing, energy supplying elements, okay. And passive elements are called those who are energy consuming, right? So here again, let us consider again a simple circuit. This is the voltage source, okay, and this is the resistor. In this R1 and R2, and this is V1. So here V1 is energy supplying, so supplying element, and R1, R2 are energy consuming element, okay. So that's why here all voltage or all energy sources are called as a active elements, okay. So all energy consuming elements like resistor, inductor and capacitor are called as a passive elements, okay. So which means here the active components are those who delivers or produce the energy, okay, or power in the form of voltage or current, and active components can provide the power gain, whereas the passive components are not capable of providing the power gain. So the passive components will consume the energy, will consume the power, okay, which is produced by the, which is supplied, not produced exactly, which is supplied by the active elements. So that is the difference between the active and passive. So active means energy supplying elements and passive means energy consuming elements. That is the major difference between the active and passive elements. Next, another network reduction technique is nodal analysis with respect to the nodes. So here, the simple way to understand what is meant by the nodal analysis. The nodal analysis, okay, or we can also call as a, what is that, node voltage analysis, okay, or the branch current method, which is also called as determining, okay, so the potential difference between the nodes in an electrical circuit in terms of the branch currents, which means, so let me consider here again one simple circuit. Right. So here, let us consider this is the node. Okay, here at this particular node, let us consider here it is the voltage V1. Of course, here V is there. So here, the nodal, let us consider here it is I1, R, I2 and I3. Okay. So here, the nodal voltage, which means node. According to the node, what we should apply? The Kirchhoff's current law. So which means here I1 is equal to, or I1 is equal to, okay, or I1 minus I2 minus I3 is equal to 0. So the node voltage equations in terms of the current that we usually write. Okay. So V is equal, here then I is equal to V1 minus V, okay, V1 minus V by the resistor. Let us consider here it is R1. So R1, which is nothing but the I1 minus I2. I2 is the current flowing through R2 and I3 is the current flowing through R3. So here V1 minus, here the potential usually we consider it as a zero potential point. So V1 minus 0 by the resistor R2, which means this represents I2, okay, and I3. Similarly, V1 minus, okay, so here R3, and let us consider only R3 here, there is no resistor, right? So V1 minus R3 by 0, which is equal to 0. So by solving this equation, we can find V1, okay, once if you get V1, then we can find I1 and I2 and I3. Because suppose if you want to find I1, then V1 minus V by R1. Okay, if you know V1, then we can find I1. Similarly, if you want to find I2, I2 is equal to V1 minus 0 by R2. So if you know V1, then you can find I2. Similarly, I3 is equal to V1 minus R3 by 0. So if you know V1, then you can find I2. So that is the nodal analysis. Then state the sinusoidal alternating waveform. Okay. So this we will discuss later. and mesh analysis definition. Okay. So the mesh analysis is very, very simple. Okay. Like same way, if you are having more than two loops, similar way. So in the mesh analysis, first we should identify how many meshes are there. Okay, or how many loops are there. There are two loops, 1 and 2. So the loop direction is based on the polarities of the voltage. Okay, so high potential to low potential. So that's why this is the loop current direction. So let us consider here it is I1. So which means R1, and here it is I2, and which is let us consider here it is R2 and R3. Okay, then write the mesh equations with respect to I1 and I2. Then you will get equation 1 and equation 2 by so, and you are having the variables of I1 and I2. Okay, so by solving these two equations, then you will get I1 value and I2 value. Okay, so if you know I1 value, then you can find what is the current flowing through R1, which is I1, and you can also find what is the voltage across R1 also. Okay, V is equal to I into R. So here V is equal to, here I is I1 and R is R1. So we know I1 and R1, you can find what is the voltage across this resistor. And similarly here also. Okay, so let us consider V2 is equal to I2 into R2. We know I2 R2, then you can find what is the voltage across R2. Similarly, voltage across R3 also. Sorry, then voltage across R3, which is V3, let us consider, then I3 into R3. So like that you can find any response. Okay, either voltage or the current flowing through the particular circuit. Right, that is about the mesh analysis. Of course, here this is the same thing that they have written. So mesh analysis is a method that is used to solve the planar circuit for the currents. Okay, planar circuits, these are the planar circuits, which means indirectly the voltages, because if you find the currents, then from the currents we can find this, like this V1, where it is, yeah, here it is V1 and V2 and V3, like this we can find. Okay, and planar circuits are the circuits that can be drawn on a plane surface with no wire crossing each other. That's what I mean. Of course, we know already what is meant by the planar circuit. Okay, so which means the branches should not overlap with each other. So those are called as a planar circuit. Okay, and a more general technique also, I mean, we call this a loop analysis also sometimes. Okay, can be applied to any circuit, planar or not. I mean, mesh analysis and loop analysis both make use of Kirchhoff's voltage law. Of course, here again, how we can write this loop equation? Okay, again the same way, here the voltage V, here let us consider V1 and V2. So V is equal to V1 plus V2. So here V is equal to V1. What is V1? V1 is equal to I1 into R1. Okay, plus here V2. Okay, what is that? R2 into I1 minus I2. Something like that. So from this equation, like this you can write. So for the nodal analysis, we apply the Kirchhoff's current law, and for the mesh analysis, we apply the Kirchhoff's voltage law, right? Because nodal analysis with respect to the node. So what is the law with respect to the node, which is Kirchhoff's current law, and mesh analysis is with respect to the loop. So what is the law that which is related to, which is associated with the loop or with respect to the loop, is the Kirchhoff's voltage law. So that's why in a nodal analysis we use Kirchhoff's current law, and the mesh analysis we use the Kirchhoff's voltage law, right? Then super mesh analysis and super node analysis. Okay, so here, yeah. Now the super mesh analysis. Okay, in a super mesh analysis, I mean, what is the major difference between the super mesh and normal mesh analysis? Or when we will go for the super mesh analysis, that is when, okay, where two meshes or two loops having a common current source. Okay, common current source, then in that particular case we go for the super mesh analysis, because let us consider here, let us draw a simple circuit with that condition. So here suppose, yeah, so in this case, as you can see here, this is the current source. The current source is in between the two loops. So that's why it is very difficult to make it, this is one loop and this is second loop, because in the first loop the same current I is flowing, in the second loop also same current I is flowing. So in this, but how this current is divided into R1 and R2, that we don't know. So that we can't find by using a simple mesh analysis. So in that case we go for the super mesh analysis. So in that super mesh analysis we take this whole as a one circuit. Okay, so by that way we can solve this problem, and we can able to find the voltage across R1 and voltage across R2. This is about the super mesh analysis. The similar way super node analysis. Then when we go for the super node analysis is if there is a voltage source in between the two nodes, again, which means again, let me draw the same circuit. Okay, V and resistor, and this is the node, and again there is a voltage source in between these two nodes. And let us consider this is another one. Okay, so here let us consider this is node 1 and node 2. In between node 1 and node 2 there is a voltage source. Okay, so in this case we will go for the super node analysis. Okay, so first of all we should know, okay, of course we know, how to apply the super node analysis or super mesh analysis, but first we should know when in which case we go for the super node analysis and in which case we can go for the super mesh analysis. So super mesh analysis is if there is a current source in between the loop, okay, then we can go for we will go for the super mesh analysis, and if there is a voltage source in between the two nodes, then we will go for the super node analysis. Then lastly, what is the major difference between the AC and DC current? As we know, we are having the two types of different currents. One is AC and DC. So AC is nothing but the alternating current and DC is nothing but the direct current. So the major difference between the direct current and alternating current is, of course, we can explain by taking any one of the parameters. So here I am explaining the AC and DC with respect to the waveform. So as we know, AC is represented with the sine wave like this. This is AC. Let us consider current I, and this is the time period. And DC, again, let us consider this is current and this is time period. This is DC. So here if you observe the difference between these, here in case of AC, both magnitude and direction of the current at every instant of time both magnitude and the current both magnitude and direction of the current is changing with respect to time. Okay, so but here in the DC, as you can see, okay, both of course the DC doesn't have any direction, okay, because it is having only the magnitude, okay, and the polarities, right? So here in the DC, okay, so the value or the magnitude is always constant with respect to the time. That is the major difference between the AC and DC. Okay, so here alternating current describes the flow of charge that changes direction periodically. Okay, of course the direction as well as the magnitude periodically. As a result, the voltage levels also reverse along with the current. Of course, because this is positive cycle and this is the negative cycle. Like that. But here DC is always positive. Of course, this positive negative depends on the polarities that we are considering. Right? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.